Are we ready to move on to the second example where we can invoke a subroutine from inside the subroutine? Now, let me just repeat again. What do we do when we invoke a subroutine? Two things to do. One is to allocate a new column so we can remember where to return to or how to continue execution at the end of the subroutine. And the second thing is just go to the subroutine and start execution in the subroutine. Right? What do we do when we return from a subroutine? Two things to do again. One is to retrieve where to continue execution. And the second thing is to deallocate the column that told us where to continue execution. So remember those two things, because these two are universal things that we will be using throughout the discussion of subroutines. So here we have a new example. We'll go ahead and start with a new one. We can close this one now. So in our new example, we'll say define sub1 again. Okay, it doesn't really matter. We say x gets x plus 1 and define sub, just like the one before. Then we define another subroutine. We call it sub2. Sub2 is going to invoke sub1. Well, we can make it more complicated if we want to. We can say x gets x times 2 and define sub. And then now we are outside of the definition of any subroutine. We can say x gets initialized to 0. And in this case, I will make it just just a little bit more cumbersome than the last one. I will invoke both sub1 and sub2 outside of the definitions of the subroutines. This one looks kind of nasty, huh? Well, but the rules do not change. All the rules that we specified earlier, they all apply the same way in this program, just as in the previous program. So we'll call this one sub2, or we can call it sub calls sub, a subroutine calling another subroutine. Do we have any conditional statements here? No, so we don't need a comment column anymore. We can start straight with a line number and also a column for the variable x. The precondition is x has some kind of unknown value, because the first thing we do is to overwrite that. Where do we start execution in this case? What is the first line to execute? Line 10, because line 10 is the first line that is outside of the definition of any subroutine. So now we start with line 10. X will get a value of 0 as a result. Then we move on to line 11. Line 11 is an invoke statement. What do we have to do when we deal with an invoke statement?
Remember the line number 2 go to.
Okay, so we allocate a column called return line number, and then we remember where are we supposed to go back to when we are done with this subroutine. So what should I put here? Wait. On column C, we have to remember line 12, because when the subroutine is all done, we're supposed to go back to line 12. Is that okay? Same mechanism as last time, different line numbers, that's all. And then what do we do? Go to the first line of sub2 that actually does something, and what would that be? Line 6. Okay, line 6 is the line. Oh, line 6 is going to invoke a subroutine again. Tell me again, what are we supposed to do when we invoke a subroutine? Allocate a column, remember where to go back to, and then branch or continue execution in the subroutine. So can we reuse column C at this point? Nope, column C is now currently in use. I haven't seen the XXXXX to indicate the column is now free, so I know the column is being used right now. So the next available column to use is column D. So now we have column D also having a label of return line number. And what do we put down as the return line number?
7.
Yep, exactly. We go back to line 7. Okay. And then what do? We go to line, we continue execution on line 2, because that's because it says invoke sub1, right? And line 2 is easy. All it does is to add 1 to x. X goes from 0 to 1. And then what do? We go to line 3. We are returning from a subroutine. What do we do when we are at the end of a subroutine? Two things to do. We have to retrieve where we are supposed to continue execution, and then we deallocate the column that told us where to continue execution. Oh, but tech, we have a problem here. Now we have 2 columns that both labeled return line number. Which one am I supposed to use? The most recently created column. Which one did we create last?
D.
Column D. So column D is the one that we use. Okay? So we take a look at column D. Column D says we continue execution at line 7. So we say, okay, we'll go ahead and continue execution on line 7 next. And then what do? The second thing we have to do when we are done with the subroutine is to indicate that column is no longer in use. Are we okay so far? Have I done anything that is different or contradicting what I did before? No. Okay? Now that's important because this means invoking a subroutine from inside the subroutine is not special. Not special in any way. Are we doing this okay? Are we... Yes? Okay. What do we do on line 7? Line 7 is saying x gets x times 2. Okay, well, we can do that. X has a value of 1 at this point. 1 times 2 is 2, and we store 2 back into x. So x now has a value of 2. Then we move on to line 8. What does line 8 do? Line 8 is the end of a subroutine. 2 things we have to do. First, we have to figure out where to continue execution, and then we deallocate the column that told us where to continue execution. Where are we supposed to go at this point? The next line to execute is line 12 according to column C. And once we utilize column C, then we say, oh, we don't need that anymore. So we mark that column as available or unused at this point. What does line 12 do? We are now executing on line 12. It's invoking sub 1. So what do we do when we invoke a subroutine? We have to allocate a column. Which column should I use now?
C.
Column C, because it is now available again. So we use that column, but every time we reuse a column, we have to give it a new label, even though it is the same as the previous one. And where are we supposed to continue execution when sub 1 is done? Post. Very good. And now that I have remembered where to continue execution, I can get into the subroutine and start executing inside the subroutine. The subroutine only has one line that is useful, which is line 2. Line 2 is going to add 1 to x. X is 2 at this point. 2 plus 1 is 3. We store 3 back into x. And then we move on to line 3. Line 3 is the end of a subroutine. 2 things we have to do. Figure out where to continue execution. According to column C, we continue execution at post. And then we say, oh, okay, since we have just utilized this column is no longer needed and it is deallocated. Okay, that's the trace of an algorithm that has a subroutine calling a subroutine. Do we have any questions about a subroutine calling a subroutine at this point? Yes?
If there's a recursive subroutine, what do you still allocate like C, D, or you keep allocating more of them?
We do not change the rules, okay? Remember all those rules, okay? The rule is when you invoke a subroutine, you allocate a column, you remember where you're supposed to go back to, and then you go into the subroutine. And those things we do not change regardless of the circumstances. When we return, almost the opposite, we go to the very last return line number column to tell us where to continue execution. Once we know where to continue execution, we deallocate the column that told us where to continue execution, and then we just continue execution at that point. So those 2 things do not change regardless of how you're invoking a subroutine. Okay? So before we move on to the more confusing case, let me just make sure that no one has any questions about this one yet. Is that okay so far? Now, if you look at a picture, if I want to highlight the picture, how the columns are being utilized, these columns, are being used from the very beginning of the execution of the program all the way to the end. If I use this color to highlight the quote-unquote lifespan of those columns, it's being used during the entire execution of the program. If I want to highlight the in-use time of these cells, this is one range. So if I want to use any color to highlight it, that will be one color. This is also marking the column is being in use, but it's in use for something else. And then these cells are also being in use, but also for something else. So I'm using a separate color here. In other words, I'm color coding the purpose and also when a cell in the spreadsheet is being used. Do we have any questions about this kind of hokey coloring of the cells? No questions? And I would even go as far as to say that this has something to do with the last in, first out concept. What is last in, first out? I mean, in a daily life, okay, forget about programming for the time being. In daily life, do we have to encounter last in, first out type of thing? Think about moving. Okay, you're moving from an apartment to another apartment. You're loading up a U-Haul truck. Isn't that a last in, first out type of thing? The last bicycle that you jam into the U-Haul truck before you slam the tailgate closed is the first thing that will fall out of the truck when you open the tailgate, right? Well, that's last in, first out. Okay. What does last in, first out have anything to do with this example here?
Well, when you're allocating the column, the last one is the first one that you
deallocate, that you utilize and then deallocate. Okay, so that's why last in, first out is very important in programming, because when you use subroutines, the order of the way you utilize the columns is exactly using the last in, first out order. Okay. Unfortunately, the refrigerator is also using a last in, first out method, unless you make a conscious, effort to not to do last in, first out. Because when you buy new stuff from Costco, what do? You put it at the front, right? What about all the stuff in the back? They continue to become a mold farm, right? Yep. So sometimes we don't want something to be last in, first out, and unfortunately, the device itself only lends itself to be last in, first out. Okay. What about when you go to a buffet place? When you go to a buffet place, they usually have those spring-loaded stack up dishes. That's also last in, first out. Okay. The first clean dish that they put onto the stack normally will not be used at all for the entire day, right? So that's also last in, first out. Okay, so we have to kind of visualize, what is last in, first out, but once we can relate it to all the stuff that you have to do on a daily basis, it is not mysterious. Last in, first out is just, last in, first out. In programming, we call it a stack, okay, S-T-A-C-K, a stack. But in this class, we don't really worry about those terms. Okay, so let's go ahead and get started with another example. Now, the next example, if you tell your other programming professors that we are introducing this concept in week 9 of a first programming class, they will just say, "Wow, tech is insane." Well, but that's no news around here. I mean, that's Okay, so in this case, we'll define a subroutine again, and we'll call this. I'm not sure whether I should introduce factorial. Maybe we can. Yeah, why not? We'll just say in factorial. And what we'll do is, instead of using the normal definition of a factorial using a loop, we'll say, if n is less than or equal to